to demonstrate how to solve a differential equation k times x cubed and plot it. Also, first we would like to differentiate that function. We'll also demonstrate in this case, since it's interactive, why we would implicitly differentiate and return a solution. We'd find the two primary approaches. One is to go ahead and form the opposite make use of the right click, separate the variables, and of course we'll have the differential equation curves, the orthogonal. We're looking for a general solution, like we are in number 4. We should notice then we would simply solve this by right-clicking. So once again, since this is not solved for y, the very first thing to do would be to we get a family of curves for different constants. So we right-click one, of course, go to differentiate and choose implicitly. A pop-up, a bit of an ugly form. That pop-up square both sides. The dependent variable is y squared equals x squared, and say plus some constant because y depends. Let's go ahead and copy and paste that. We'll also solve for y prime and just give us the right-hand side. And to simplify it, let's take out the y of x and just call it y prime. And also call it still has k in it. C. We could replace k. A couple of different ways to do that. We could right-click back here. Maple doesn't usually offer that with the highlight and hover k. So if we simply manually do that, replacement for k, we can copy and paste that. Put it in place of k equals x squared plus a constant first. Paste it. In place of k, we can highlight y squared over x cubed. The x squared. We'll offer copy and paste. Subtract it from the other side. Also manually type it. Doesn't really want to do that. But when we press enter, we get y prime hyperbolas without the k. You can copy and paste this. This is the slope formula for this function. Of course, again, orthogonal family of curves would have an opposite reciprocals in here. So it would be negative 2x. We divided by 3y. Variety of graphs. That's the derivative, right-click, differential equation for the orthogonal family. And if we right-click on that, we can solve the differential equation for y, and we get the family of curves. It's in a rather ugly form. Right-click, we have a positive version, 2D and a negative xy. We see, and we should note that if we square both sides, we could get rid of that radical. If we wish to solve with an IVP, the process is slightly different. So probably would go back here, to copy and paste this and just edit it. So press enter and right-click on that differential equation. Take out the y of x. Notice it offers add an initial condition. Nice form of the equation. So now we're going to solve the specific curve. Let's get rid of 9 times and that's the one that goes through 0, negative 3. And yes, we type that in under the add additional, multiply both sides by 3 if we highlight that. Click OK. Offers. Now we're looking for the function that satisfies both of these conditions. By 3 satisfies this differential equation. If we square both sides, it also goes through this point. Maple doesn't typically want to offer that. If we click on it, it doesn't. It only offers to exchange sides. It gives us a specific solution. We can easily enough manually do that. So we have 9. We can highlight that and right-click and say plot. Notice that it only gives us equals the bottom half. We would need to change our axes. In fact, probably want to square both sides again to get plus a constant. Again, so that's the fast way to necessary, but we just right-click that on the other side. If we highlight it, it'll offer to subtract that. Another approach is to solve interactively the family of curves. So if we go back up here and right-click, it offers different constants. Now what we want to do is plot several of those. A pop-up window opens. So highlight it, and it does not list the initial condition. I'm going to paste it in several times with commas in between. At 0, we can simply make up some constants here. The value is negative 3. Suppose we choose 9. Click on Add. Suppose we choose 1. Click on Done, and it puts in that we have 2 requirements. The function has to satisfy this differential equation, and this is when we right-click, we can graph those ellipses. If we click on Solve Numerically, it applies numerical methods to get the function's graph. Implicit plot. We click on Solve Symbolically, and at first it looks like circles. If we click on it, and it gives us the specific curve under the graph. And if we click on Plot, it gives us that plot. We see that it's a little bit restricted in how you can vary this. If you click on a little wider, they are a little wider than they are. You cannot change the window. Now we also want, it's true that sometimes we'll get a constant down here. You could put the constant y squared equals kx cubed. If we didn't have the copy and paste that constant entered with IVP a math line would offer it a C1. We again can put when we click here between, it offers we could either return a solution or a plot. Edit the one of the graph. We could click on number. How about 1? It would insert the graph. How about 5? If you go back, it's quick enough to do that. Negative and 2. Again, it doesn't have the initial condition. 3. We could add the initial condition again, but let's just click on solve symbolically. Press enter. Click on solve. It offers another type with different constants. I need a comma right there. You're going to find that when it finds these, and we can highlight these and drag and drop them. It does not want to plot that, and Maple will add them in. So you would need to have the initial condition in for this. And I'll drag and drop one at a time so we can see that they are curves with a sharp turn. And as we add them all in, we get a rather small graph. We can edit that graph by clicking on it, going to Axes, Properties, and choosing a window ourselves, maybe -5 to 5 in both directions. Click on Apply, and yes, it's true that these families of curves intersect everywhere at 90-degree angles, and so the trajectories, the paths of those functions are orthogonal.